Good afternoon. My name is Karine Habshi, and I'm going to teach you the Energy Economics and Policy course. To start with, we'll go over the syllabus. This course will aim to develop an understanding of the fundamental economic concepts and theories as they apply to the energy field. This is why, in the first part of the course, we'll do a review about, if you want, energy, everything related to energy, renewable energy, let's say green buildings, what are the energy efficient strategies to reduce energy consumption, etc. And then we'll develop several economical tools to assess, if you want, the economical benefit of a project, if we should continue with it or we should change our mind, etc. So this is an overall the purpose. So the topic studied will include the economics of natural and energy resources, the interrelationship between energy, economics, and the environment, as well as some important issues in energy policy. So energy policies also are very important because, for example, that for renewable energy, when we started with solar systems, the cost was really high. So no one will invest if the government will not impose this. So energy policies helped into the advancement of the technologies related to renewable energy. So we'll see together, for example, in this course that if we take the case of PV, at the beginning, the cost was really high, but with the advancement of technology and with the push given from government that forced people to use with a certain percentage solar energy, led to a very high improvement in this technology. And at the end now, PV panels are competitive with fossil fuels. So from here, the importance of energy policies that we'll go over them. In addition, the course will also demonstrate the use of economic tools for decision making in energy and environmental planning and policy. This part is very important because sometimes when we need to make decision, we need to consider several factors. And these factors might be very different. They have different units. Sometimes, if you want, we have things that are of high importance, for example, on the human level, but not important on the economical level. But we should include them. And for example, if you want to introduce a project, and this might lead to the increase of people with cancer, this is bad. And we need to take a certain index, let's say the number, the probability of having increase in percentage of human cancer. This should be considered in the analysis. And how we can compare this with the cost, for example. These two factors are very different. So we need to come up with techniques to normalize the index and to put weights, if you want, depending on the importance of the issue we are considering, in order to do a final decision. So we have several tools that will help us into drawing what we call the decision matrix, if you want. We decide on the important factors that we should consider. These factors will be economical, environmental, etc. And we'll learn how to come up with calculation techniques that will allow us to put like grades and to put weights and come up with a final grade that will allow us to decide which alternative we can go with. Furthermore, we will cover a number of contemporary energy and environmental policy issues, as we mentioned before, including the energy security, global warming, so how to reduce global warming, how to take this into consideration whenever we do the decision matrix, what are the regulations of energy industries, energy research and development, etc. So this is an overall the course learning outcomes. Concerning the content, to start with, as I mentioned, we'll do a small revision related to energy. So first we'll introduce the course energy economics and how we will relate the two fields. We'll do a global overview of energy. We'll go over the main steps needed in the design of energy systems. And this part is very important for your project because, as we'll see, a major part of the course will be to conduct a project. In this project, we should take a certain energy system. We'll try to go over the design from zero. So we'll do the different steps and we'll use an energy software to do the simulation of the system. We need to perform simulations because at the end, The idea of this course is to compare several alternatives, if you want, and use economical tools in order to decide which one is the best approach. So we need to know what are the different design steps, and we'll apply them on the project we consider. Um, Concerning energy systems, we have a lot of options. So we can, and in this course, we'll tackle several ideas, and I will talk in brief about this. So for example, let's say one of the possible topics is the following. Let's say you have a home or a residential building, or a building of offices, etc. It can be any application, and you want to install a certain renewable energy system, because in Lebanon we encountered a lot problems of electricity, cost of electricity, and for a long time period, we don't have electricity 24 hours. This is why we thought a lot about implementing renewable energy in buildings. So if you want to decide which type to use, you have several possibilities. And even if you just take the solar system, you have several possibilities. You have, let's say, concentrated panels, you have PV panels, etc. So you might need to make your decision, you need to consider the different strategies. Let's say, for example, solar PV or concentrated PV, etc. Okay. Now, if you want to decide which one to use, you need to simulate your system. So if I want to use PV, what is the number of PV cells I need? What is the cost? And let's say what is the negative effect of this on the environment? So I can put what we call the decision matrix. Let's say I build it. I say first an important factor, let's say, will be the cost. Another factor, let's say, the maintenance. In case, for example, I want to compare also with wind energy, and if I don't want to use solar energy, I want to use wind, then an important factor will be the noise effect, etc. So I select the most important factors concerning my project, and then I put, I have several alternatives. So I say alternative 1 is PV system, alternative 2 is concentrating panels, options 3 is wind energy, for example. And as we mentioned, so we have several techniques that here we'll learn how to decide on the criteria and how to come up with a normalization technique to be able to put grades. You can put a grade from 0 to 10, and we'll see how to do this. Okay, and then depending on the importance of the factor, let's say maybe the cost is the most important one, you put a higher weight for the cost. And then when you put grades and you consider, for example, the cost importance is 50%, for example, for the maintenance, let's say 20%, for the noise 30%. After you put the grades, you can calculate the average weight. And you consider the average, but considering weights, different weights for the different factors. And let's say this is 30%. And at the end, you can get a total grade for each alternative. Let's say if you are close to 10, it's very good. If you are close to 0, it's bad. So you can compare the final grade, and then you can decide which option is the best. So we'll learn these techniques that will allow us to select the best alternative between the one you are comparing. So this is an overall what we want to do. Now, concerning, so this part, as I told you, is a little bit review on energy systems. And here we'll start with economical tools. So we'll go over financial appraisal of energy technologies. Since electricity is one of the most important parameters, we'll study the levelized cost of electricity, LCOE. Then we'll consider strategies if you want to improve the use of renewable energy. So as I mentioned for you, renewable energy is very attractive because it's free, because we don't have a lot of bad effects for the environment, etc. This is why we need incentives. We need to encourage countries in order to use renewable energy. And we always first need the government to help us at the first stage, and with time these technologies can be competitive in the market with fossil fuels. So this process will be studied, and we call this de-risking. De-risking renewable energy investments. So we try to enhance we can do this on the technological level. We can do this by, if you want, encouraging people to use this energy by because the government, for example, can help this field. Okay, so you can put money, the government can put money to help this field until it can compete with the conventional market. So we have a lot of other strategies concerning de-risking. We'll study them in this part. In addition, we'll learn how to perform the cost-benefit analysis. So here we can do a balance between the cost and benefit in order to make sure that any projects that we want to go over will lead to gains at the end. Plus, we'll learn how to put the important criteria whenever we want to do analysis of a project. So this is the multi-criteria analysis. And at the end of this part, we will be able to study a project and compare different alternatives in order to make a final decision. And all of these parts should be included in our project. Okay, so until here, you can start the project from now, and we'll discuss next time together what are the possible topics, what software can you use for simulation, and I will help you with this. I will introduce you to several softwares performing energy simulation. We'll go over ANSYS Fluent, Energy Plus. If you are familiar with softwares, for example, for solar energy, you can use them also. So we have a lot of options, but at the end in your project, you need to use a simulation of an energy system because you want to compare several alternatives and you want to apply the knowledge that you will acquire from the course in order to select the appropriate choice for your problem. In the final part, we'll go
Professor,
over. Yes.
Sorry for asking, but how many people per group in the project?
You can, in general, 3 people, but if you want to have 4, it should be a big work. Okay.
Okay, thank you.
Welcome.
Thanks.
So we have in the final part, we'll discuss issues as energy security, energy policies, the social cost of carbon, and we'll go over economics of fossil fuel supply. So this is an overall the course content. Now I want to discuss with you also some other ideas that you can use for the project, because I will give you some possible topics, and you can take this week your time to think about ideas that might be of interest for you. So we already mentioned the case of, let's say, implementing renewable energy to buildings. Another important topic can be green buildings. So you know that and nowadays, when we want to build a certain building, we should follow a lot of codes and standards in order to reduce the energy consumption to reach what we call passive building. So we'll do a small revision about this. What is a passive building and what is a positive building? And our final aim will be to reach a positive building. When we say a positive building, this means that the building can produce electricity instead of just use electricity. So we can contribute to energy production. And in this case, we say that our building is positive. How we can do this? We can implement a lot of energy efficient strategies that will allow us to store energy and then deliver it to the buildings that we have. And if we have an excess, we can deliver it to the grid. Okay, to the national grid. So green buildings is a very important topic, and we can have a lot of projects related to it. We can consider, for example, it's a case of retrofitting of buildings. What we mean by this, you know, that if you have an already existing building and you want to enhance its energy efficiency, you can try to implement some strategy. For example, for the envelope, you can, let's say, add some layers, because this will reduce the heat losses from the building. You can also implement renewable energy. Let's say you can add solar systems. You can use PV walls if you have constraint in space, for example, at the roof. Instead of just putting your PV on the roof, you can have construct like PV walls. Of course, yani, with good architecture, yani, to not have a to preserve the aesthetic of the building. Okay, we have a lot of nice things that can be done. You can put shading, so you have a lot of technologies. So here, if you have a building, you can try to simulate different strategies, okay, in order to enhance the energy performance of the system. And you can compare these strategies. And sometimes a strategy might be very good, but the cost is really high. So what we can do, we can compromise between the two by doing the calculation using the multi-criteria analysis. So when we build the matrix and we put grades on the different factors, we can come up with the best alternative, which will be a compromise between energy efficiency and cost. Okay. So retrofitting of buildings can be an idea, or also if we are building if we have to design a building from zero, we can then this is much better because we have the option to play more with the envelope, with the orientation of the building, etc. So in this case, you can use, for example, Energy Plus as software to do simulation. In the case of solar energy, you can use PVSys if you know it, or as I told you, I am open to any energy software that you are familiar with. And in case you are not familiar with any software, don't worry. I will introduce you to several energy softwares that can help you in doing your project. Now, another approach also concerning energy is heating and ventilation. So you know that one of the major contributor to energy consumption is heating and ventilation systems. Okay, so HVAC systems. So what we can do, we can try to improve the design of ventilation systems in order to reduce the energy consumption. And here we have a lot of possible techniques, and we can talk about them after. Yani, we have what we call mixed ventilation, which is the conventional method used. You have displacement ventilation. In this case, what is the difference? In mixed ventilation, we just supply air from the top level. We allow it to mix in the, let's say, in the room, and then it's exhausted, let's say, from the ceiling in general, in majority of cases from the ceiling or sometimes from the floor. So this is mixing ventilation. But one of the disadvantages of this method is that we have a high energy consumption. To avoid this, for example, we can introduce air from low level. In this way, let's say during the summer, cool air will spread in the occupied zone, and then it will be heated and it will move upward to be exhausted from the ceiling level. So we can create like a stratification in the space. You have here a cool zone and here a warm zone. And since what you care for is really the occupied zone, which is, let's say, below 2 meters, you don't care if you have high temperatures here. So in this way, you can reduce the energy consumption and ensure comfort of your occupants. We can simulate several scenarios using what the software ANSYS Fluent. So the ANSYS Fluent software that I will introduce for you can help you to simulate airflow in buildings, and it will help you into conducting a project, let's say, that is comparing different ventilation configurations. Also, ANSYS Fluent can be used to simulate heat exchangers. Any heat transfer, if you want application, can be simulated with ANSYS Fluent. So you will be introduced to this software in case you want to use it. Okay, so this is the course. This is about the course content. Now, concerning the textbooks, of course, the slides that will be provided for you are enough. But in case you want to have some extra readings, you have a lot of reference books that you can go over. The first one is Handbook of Energy Economics and Policy, Fundamentals and Application for Engineers and Energy Planners. You can go over also the second book is Energy Economics, Concepts, Issues, Markets and Governance. And finally, the third reference is Environmental and Natural Resource Economics. Now, concerning the grade distribution, your participation and attendance are highly appreciated. I'll put 10% on this. For the project, you have 30% of the grade on the project. The project will be divided into a report and a presentation. And I will follow up with you during class time on the project if you need any help, if you have any questions, so we can work on it progressively. And you have a midterm on 25%, and for the final exam, it will be on 35%. Okay. Any question on this? Okay. Now I will start with a small introduction to the course, and then we'll navigate a little bit on the Moodle page. So let us navigate on the Moodle page first, and then go over the introduction before you introduce yourself. So in the Moodle page, you can find first the course syllabus, then the course material that we describe in the syllabus. So you have, as we mentioned, several topics that will be tackled. In links, you can find, first you can find Zoom links that we use in, if you have any question, we can, of course, we can have office hours on campus after class. And in case you need to ask questions off campus, we can organize an online meeting using the Zoom link that you use now for the live session. I will post for you all recorded sessions in case we have another recorded session. They will be posted on a YouTube playlist, so you can access them when you want. This ANSYS link contain recordings that can allow you to be introduced to ANSYS, and of course also will have on-campus sessions together to practice on it. In case you selected to go over the simulation of buildings, also I introduced for you here Energy Plus. So you have an Energy Plus link that will help you into learning the software. And the WhatsApp link is the one for the WhatsApp group of the class. And for the project, next week, hopefully, I will introduce for you the project guidelines, and you can start to form groups, and we can discuss. If you have any other idea, of course, you can suggest it, because any topic that is related to energy, and we can simulate economically the project, and we can have simulations using software, you can propose the idea, and of course, if it's related to the course, I will accept. Okay. So I want you to think about the ideas I proposed for you today. And of course, if you have any suggestion, you can give it to me on campus next time. So we can form groups and we can start to work on the project. Now I will start with a brief introduction to energy economics. As the name indicates, energy economics is a subset of economics for application to energy projects. And it's a very important field. Why? Because engineers will use it a lot. Ages ago, the most significant barriers to engineers were technological. The things that engineers want to do, they simply did not yet know how to do it or hadn't yet developed the tools to do. So for this reason, we had a lot of advancement in technology in order to overcome these problems faced by engineers. And in the majority of these problems, the economical aspect is of high importance, because sometimes we can come up with a very original idea on the scientific level, but economically it's not viable, because whenever you propose an idea that will not allow you to gain money, no one will invest in it. And as we mentioned at the beginning, let's say at the beginning of solar energy use, the government has to put extra effort to put money in order to encourage people to go and use renewable energy. And sometimes we put policy to force them to use it, because if we don't do this, no one will invest in something that will not allow him to gain. Okay, so this is why the economical aspect is always very important whenever we propose any technology in energy. So there are certainly many more challenges like this which face present days engineers, and this is why we need to develop tools in order to help engineers into coming up with decision and select the appropriate idea at the end. So to start with, one of the challenges is related also to natural resources, because these natural resources are becoming more and more expensive. If we consider fossil fuels, for example, we have now a problem that these resources are finite, and plus they are causing a lot of bad effect to the environment. This is why we need to come up with new strategies. Of course, renewable energy is the future, and we are trying a lot to improve techniques using renewable energy because we hope that one day these strategies can be competitive with fossil fuels, and then we don't need to use fossil fuels which are very harmful to the environment anymore. In addition, as we mentioned, negative side effects of engineering innovations should be considered. So whenever we have a strategy, even if on the economical level it's very good, it might be very harmful to the environment. So the environmental factor should be considered. And we know that in general, any investor will consider the priority to the economical level. This is why government should always put, if you want, regulations in order to avoid air pollution or to reduce it as much as possible. We can impose, for example, taxes. We'll see what are the different strategies. Let's say the government can impose taxes depending relative to the emissions. So higher the emissions from an industry, larger will be the taxes the industry should pay, etc. So we'll learn all of this in energy policies and regulations. So engineers must decide if the benefits of an energy project exceed its costs and must make this comparison in a unified framework. The unified framework is what we talked about in the introduction. So we need to make a decision matrix. We want to normalize the factors in order to be able to compare them. So the framework within which to make this comparison is the field of energy economics, which strives to answer exactly these questions and perhaps more. So energy economics will help us into making decisions. In energy economics, we'll assess the appropriateness of a given project, will estimate its value, and justify it from an engineering standpoint. Energy economics is the application of economic techniques to the evaluation of design and engineering alternatives of an energy system. Now, what are the main steps? And we should follow these steps in our project. So we have 4 essential steps in formulating energy economic decisions. First, the creative step, the definition step, conversion step, and decision step. Now we'll go in detail over these, and I will take, for example, the first example I gave you. If I want to implement, let's say, a renewable energy strategy in order to create electricity. So what is the first step? The creative step consists of finding an opening through a barrier of economic and physical limitations. So if we take the example of a certain residential building in Lebanon, what was the challenge? No electricity. Okay, we have a lot of lack of electricity and high cost of fuel. So we need to overcome this barrier. So we start to search for alternatives. Okay, so we explore and investigate some solutions, and we do some research, let's say. Of course, in this case, we can see in other countries, they use renewable energy, so we can do this. But sometimes you have a problem that is very new. So if you have a new problem that was not tackled before, you need to do research. And sometimes we need to improve, we can come up with an original idea or have a technological advancement in order to solve our problem. So here in our simple case, we can consider what are the different alternatives that can use renewable energy like solar system, wind system, etc. Okay, and then we want to compare them in order to select the most appropriate one. So many, and sometimes you might combine several strategies. So one very successful solution in Lebanon was to combine solar and wind energy, because solar energy might not be enough because you don't have it all the time. Okay, and in many regions you have both sun and wind. This is why combining these two can allow us to supply electricity for a longer period of time. So many successful ideas are simply new combinations of known facts. So we have to develop techniques, we just combine them to come up with a new design. Now, concerning the definition step, in the definition step, we define the alternatives originated or selected for comparison. So let's say in our case, I want to compare PV, wind, or combination of both, let's say. Okay, if I want to install both systems, of course the cost will be larger, but I will provide more electricity. Okay, then the choice is always between alternatives, but we also need to choose which alternatives to consider. This means that sometimes you can have a lot of ideas. You have 10 possible ideas. You can use hydropower also. You can use other types of solar systems, concentrated systems, etc. You have a lot of solar techniques. So you might have a lot of choices, but at the end, you need or to limit your choices. Sometimes you can go to conventional techniques, or if you explore larger number of choices, your final decision might be better. So it depends also on the time you have to make this. Okay, so is it better to spend more time defining more possible alternatives, or to take the decision fast considering only few? This depends on the time you have to decide. Okay, of course, when you consider a lot of alternatives, this will give you a larger choice and you might end up with the best option. But in case you are restricted on time, you should do a preliminary selection and then compare the main alternatives that you consider. Now, what about the conversion step? In order to be able to compare the alternatives, we need to convert them to a common measure. And this is a very important step. Okay, so as we mentioned, sometimes we are comparing factors that are really very different from each other. So we need to normalize, we need to come up with a unified framework. And we will learn how to do this in the chapter of multi-criteria decision matrix. Okay. We express each alternative in terms of cash flows at specified date in the future, and state also those considerations that cannot be reduced to money terms. This is very important. So sometimes, okay, you have, as we said, aspects related to the environment, related to human being ethics that are very important and cannot just be quantified by money. So whenever we want to take into consideration all of these factors in one framework, we need to use strategies that, as we said, will develop let's say grading techniques with some weights for each factor, and this will allow us to make a final decision depending on the total grade of each alternative. Now, in the decision step, having done all of the above mentioned, we need to decide what to choose. We can consider multiple criteria, cancel out identical factor, and stress the attention on differences. Of course, whenever you compare different alternatives, you don't consider what is common between them. So you should stress the differences in order to be able to make your final decision. And sometimes when facts are missing, you need to use judgment. This is why, in general, we select appropriate people with expertise about the subject in order to help us into making decisions, because sometimes we have to do some judgment. And at the end, whenever we are done, we can make the final decisions. Now, concerning the course learning outcome, so this course will aim to develop an understanding of fundamental economic concepts and theories as they apply to the energy field. And we discuss all of these issues in the syllabus. And here again, you can see the different chapters that we will go over in this course. Any question on this? Okay, I just still need I want you to introduce yourself. So just I will open a new meeting.